Dear viewers, greetings. In this video, we're going to analyze the model summary. The training is successful. The training we set in the previous video was made of 10 epochs. These are not enough. We don't have the better result, but we have something to discuss on. At least we have a model that's capable of recognizing successfully or almost successfully the plates of 3 cars. This one as I sorted out. If you need better results, we'll do more training. I mean, we increase the number of epochs. Train until it gets better. But this is enough for now. It was the best try, the first try. So let's discuss what it left us. When the model finished, when the training, the model was finished, it left us this summary that we're going to discuss briefly about. It left the summary talking about the classes it went through. These are the classes it went through, it was trained on, and the images in the validation set. Remember in the previous videos where we were setting the data set structure, in images we've set validation and train. Remember something like train val, or you can just go there to let you see, or we can just go them using GUI. In the data set, you remember we had images and labels, and in images we had a train set and a val set. A train set is made of the pictures it used during the training, and in the val set there are images it used during validation. Where does the validation take place? After every epoch, it will try to test itself and see what's capable of doing after acquiring some knowledge during the training. It will go through a validation set, trying to test itself on every image in the validation set, trying to see, am I capable of correctly finding the label? Am I capable of correctly predicting the noun plate? So it will test itself and it will be giving itself marks. Oh, hi, my God, I'm still bad here. I know this is this such plate number, or such an plate, but I'm incapable of predicting it. So it will test itself and giving itself score, and that's what we're going to see. Well, where does the number 183 come from? We in that validation set, if you count the number of images in the validation set, we are in the data set, as you can see, and we go inside images. We try to count val. Here we have 183 files in the validation set. Yes, you are correct. In the validation set, we have 183. That's the number here. So there is 183 in a validation set. So if you take a number like this, the first one, we'll see that it has 8 instances. What are instances? Instances are objects in the whole data set. This is the total number of the whole validation set. This is the number of this particular or number of object of this particular number plate. And this is the precision, and this is the recall. R is for recall, P is for precision, and map 50 and map from 50 to 85. These are the mean average precision. So what's precision? As I told you, precision goes around with goes together with the run. No, with the recall. R is for recall, run. Sorry. P is for precision. So what's the role? What's the model doing during the training and during the validation? During the training and during the validation, the model is basing on knowledge it already had and is before training, and is basing on the label you made, the label you made on the picture, is first going through an image, trying to find the location of the label as you set it during labeling. You remember you labeled using label image, and when it finds the label, it finds the square oh no, not the square, the rectangle, the bounding box. It will also try to find within that bounding box if it can find the label. Sometimes it can't because maybe the car was far away, maybe there was a shadow. Sometimes it can't find well the label within that bounding box. That's in the recall. And then in the precision, when it finds the label, during the training, it will train itself, try to know different features, identifying that label. That's what happens during the training. But during the self-test or validation, it will try to see if it's capable of confirming with the data scientist who labeled that number plate. If it will try to see if it can confirm with him or with her, and if it can, it gives itself 1, it marks 1, and when it can't, it gives itself 0, and in the end it will count the precision. Which precision do I have? And in the recall, as you remember, for the recall is about finding first the bounding box and the label inside the bounding box, and this average is the mean precision. Like if my precision measured at 50%, how good am I? And my precision measured between 50 and 90%, how good am I? So about precision, this is what's said about precision. It says, out of the times I predicted RAG that 30p, how often was I correct? So this is what precision is about. And a recall is, out of all the actual RLG that 20p instances, how many did I correctly identify? This is recall. And MAP or MAP is mean average precision. There are two types, measured at 50 and measured between 50 and 95. The bar is raised high. So do not worry, we'll make a video, or it's not even one video, we make videos about metrics, because there is a lot to talk about metrics. So according to the precision, good precision, and instances, and recall, and mean average precision, I sorted these this summary. I sorted it out, and I found that we have 3 nameplates with the best result. Don't worry, if we do more training, we increase the number of epochs. These two will have a lot of nameplates that the model can detect, but for now, because we set only 10 epochs, this is also good. So let's make some test or inference. We call it inference. Inference is testing the model. So we'll do 2 types of inference. Now we'll do inference on picture, and we'll do inference on a video. This is MP4, and we should do inference on live feed, but we are not doing it now. We're doing it later. Live feed. Yeah, well, so let's go ahead. Yeah, that's for no video. Live feed. Okay, so let's go doing the inference. Okay, I have prepared some pictures. If you can see, in data images, I have some pictures. This is the picture for Costa 1. This is the picture for Costa 2. This is the picture for this minibus. But we want to go. This is the picture for the Prado. We won't go through we will not do a inference on every picture. You will be able to do a lot in your practices. And also I prepared a video. This is a short video, and and we'll do inference on this video and see what we are capable of doing. Okay, so let's get started with inferencing. I'm copying this command, and what's in this command? There's we're using Python, and we are running the file detected.pr. We are using the knowledge called last pt. Okay, where is this last pt for PyTorch? At the end of training, if you go in the name of the project, at the end of training, it has saved the knowledge here as the best it knows, and the last it saved. So this is the knowledge package we're going to use, and this is the size of image, and this is the confidence score. The confidence it means if it has less confidence that it's likely to find and predict the label. Less than 25%, it will ignore that. It will only predict when it has the confidence above 25% that it can do it. So this is the source where the picture is. I showed you this picture earlier. So let's predict. It predicted. This is the size of the picture. It predicted it saw one label, one nameplate, and it was this one. It was this. It predicted. Let's see, and it was saved in the runs detect as XP14. So let's go in the runs. Yeah, we have runs inside the YOLO5 folder. Have runs, and we go to experiment 14. Tada! Yeah, it was correct. Yeah, it was correct. Very well. And let's try to do the same for the Prado. For the Prado. Okay, for the Prado, it saw one nameplate on the picture, and it predicted the Prado has this this number, and it did it within this time, and it saved the result here. Let's go in the experiment 15 and see what it has as output. So it predicted with the confidence of 81%, and it was correct. So let's try to do inference on the video. Remember, we have the video here. We have the video stored in the data videos. We have this Costa 1 MP3. So let's get to the video. It's saved in videos as Costa. So it is started. It's targeting 813. What's 813? These are the frames the video has. Yeah. So during this inference, it's going through every frame. It's taking a while, but it's going through every frame. It will go until and to every frame it's giving it the results. If they can't find it, it says it. If they can't find it, it says no detections. Because there are times when it finds it, it's video. There are times when it finds it. There are times when it can't see it. We are almost there. Okay. For some reasons, it didn't reach there for some reasons that I will try to know later. I don't know myself why it didn't go up to 813 frames, but that's okay. It saved the result in runs detect XP16. Let's go there and see what saved for us. In the rounds detect XP16. This is what it has. This is the video. This is not the video it made. It's a video it made. You will see it. Okay, we didn't have this. Now we have this. So it's predicting, correctly predicting, It's amazing. Okay, so this is the video it made. And well, we'll have enough time to discuss about what happens during training, during inference. We'll have enough time to discuss in detail. But what's good is we have at least some results to discuss about, and it's not only these metrics it prints here. It's also there are also some files at the end of training in given projects. It will give out different files during the training. It will generate the confusion matrix that we'll discuss about later. It will provide F1 confidence curve. Some confidences are just short, and some for these three number that I showed you, the confidence too high. Let's see the for example, this color is RH 593C. Yeah, the confidence is high. And for this blue one, RAC6, yeah, this the confidence. No, this RAG320P. Actually, those are the numplet we found by trying to sort based on higher precision value, higher precision value. So these are these numbers for these plates. You see them? These are the same three numbers we have here in this confidence curve. These ones, the confidence curve. So the confidence will increase. There are some that didn't go far in the terms of confidence. This had tried, but the confidence still low. What's this? It seems this is RAC697T. But these with high confidence are this color RH593C and RAG20P and RH213. This is what it's printed out at the end, and it matches well with our sorting. And there are more. There are what we call labels correlogram. We'll discuss about this later. And then printed the labels and the instances they have. Generally, this has higher number of instances, this has lower number of instances, and yeah, it also printed P precision curve. This is the precision curve. Well, some precision continued the precision was just dead in the beginning. And this is precision R, precision recall curve combined. This is a recall curve, the capability of finding the label and finding the bounding box in the label. Again, we have three that survived. And this is what it prints during training. This is what I'm seeing. This is what I'm capable of doing. This is how I'm performing. It prints these during training. To try to print what's seeing, and during validation it prints what's seeing too. During validation prints what's seeing. That's during the training. As I told you, at the end of epoch it will validate itself. So this is the validation demands, and it seems we need to do more because it can't generalize well. It worked on a few cars, so that will be fixed in the next trainings. But this is okay for now. So what are you going to do now? You're going to do the same and do more now that you know where we are and where we are heading, how to do better. You can do better. You can increase the number of epochs. You can get engaged and have fun. Thank you. See you in the next video.